Look up tonight. It's gone. The oceans feel it first. Not in an hour. Not tomorrow. In minutes, the water begins to move in ways it hasn't moved in 4.5 billion years. Because the one thing that has controlled every tide, every current, every coastal ecosystem on this planet, since before the first cell of life divided in a prehistoric sea, is no longer there. The moon is gone. Tonight. Right now. And in the next 15 minutes, I'm going to show you exactly what happens next. Hour by hour. Day by day. Until the world you recognize no longer exists. Before we begin the clock, we need to understand something most people get completely wrong about the moon. It is not just a light in the sky. It is not just a destination for astronauts. The moon is an engineering system, a gravitational anchor, a climate stabilizer, a biological metronome that every living thing on Earth, including you, has been synchronized to since the beginning of life itself. The moon stabilizes Earth's axial tilt at 24 degrees. That precise angle is why we have 4 different seasons. Why the poles are cold and the equator is hot. Why agricultural civilization was even possible. Without the moon's gravitational counterweight, Earth's tilt begins to wander. Freely. Chaotically. Anywhere between 0 and 85 degrees, over thousands of years. The moon generates tidal forces that move 400 billion tons of water twice every 24 hours. Those tides oxygenate the coastal waters where 70% of Earth's marine life begins its life cycle. They drive the ocean currents that regulate global temperature. They have been doing this, without interruption, for 4.5 billion years. Coral reefs spawn by the full moon's light. Sea turtles navigate by it. Wolves and predators time their hunts around it. The human menstrual cycle, 29.5 days, mirrors the lunar month almost exactly. The moon is not background decoration. It is the metronome to which all of Earth's biological systems are tuned. And tonight, it stops. The moment is instant. The moon doesn't fade. It doesn't drift. It simply ceases to exert gravitational influence on Earth. And the ocean, which has been pulled toward the moon's position for 4.5 billion years, suddenly has nowhere to go. The tidal bulge, the enormous swelling of water that follows the moon, collapses. In coastal regions that currently experience high tides driven by the moon, the water retreats. Dramatically. Harbors in Boston, London, Mumbai, Shanghai, suddenly sitting in water 3 to 5 meters shallower than this morning. Ships run aground. Ports go silent. And on the other side of the planet, the water the moon was no longer pulling, surges. This is not a tsunami. A tsunami is a wave, it arrives and retreats. What begins happening in the first 6 hours is a gravitational rebalancing. The ocean, freed from 4.5 billion years of lunar discipline, begins redistributing itself according to Earth's own rotation. The equatorial bulge of water increases. The polar oceans drain. Coastal elevations that were perfectly calibrated to lunar's gravitational influence are now wrong. By hour 3, the marine ecosystems in shallow coastal zones begin registering catastrophic stress. Coral polyps that spawn by the full moon's light are firing their reproductive signals into darkness, receiving nothing back. Filter feeders that depend on tidal flow for food delivery are starving in the same water they were born in. The ocean hasn't left, but the rhythm has. By hour 6, the global thermohaline circulation, the system of ocean currents that acts as Earth's climate control system, begins to slow. The Gulf Stream, which keeps Western Europe 15 degrees warmer than its latitude should allow. The currents that carry cold, nutrient-rich water from the deep to the surface, feeding the marine food chain from the bottom up. All of it was fine-tuned over billions of years to work with the moon. Without it, the machine is running without its governor. But here is where the scientists in the room start going very quiet. Because it's not just the oceans. The moon's gravitational influence doesn't just affect water. It affects the entire planet. Earth tides. Most people have never heard of them. The solid rock of Earth's crust flexes by up to 30 centimeters every day in response to the moon's gravitational pull. 30 centimeters of solid planetary rock, bending. Like a massive, slow-motion elastic deformation of the entire surface of the world. When the moon disappears, that stress pattern, the one the crust has adapted to over 4.5 billion years, suddenly changes. By hour 8, seismologists worldwide are watching something they have no language for. Not a single massive earthquake. A distributed seismic response, hundreds of small tremors, globally synchronized, as the planet's crust stops experiencing the tidal stress pattern it has maintained for 4 billion years. The fault lines that have been loaded and unloaded by lunar gravity on a 24-hour cycle are now experiencing an unprecedented stress pattern. The geological trigger mechanisms being reset. Volcanologists are noting increased magmatic pressure in monitored systems globally. The moon's tidal flexing of Earth's crust acted as a pressure relief valve for the planet's internal heat, rhythmically squeezing and releasing magma chambers on a precise schedule. Without that schedule, pressure is building in systems that haven't experienced unconstrained accumulation since the planet was young. By midnight, 12 hours after the moon disappeared, Earth's night side is darker than it has been since the last ice age. The moon provides up to 0.3 lux of light, enough for human night vision to function. Enough for nocturnal predators to hunt. Enough for migrating birds to navigate. For hundreds of millions of years, Earth's night has never been truly, completely dark. Tonight, for the first time, it is. The impact on the living world is immediate and total. 90% of Earth's predator species time their hunts to the lunar cycle. Moths, which pollinate 40% of night flowering plant species, navigate by the moon. Every night migrating bird species on Earth uses lunar light as a navigational reference. In one night, the behavioral programming of 10,000 species simultaneously fails. By the end of the first week, the scale of what's happening begins to register not just in the oceans, but in the economy of life itself. Because the intertidal zone, the stretch of coastline between the highest and lowest points of lunar tides, is one of the most biologically productive ecosystems on the entire planet. Without lunar tides, the intertidal zone simply stops existing. It becomes a fixed waterline. The barnacles, mussels, sea stars, crabs, and hundreds of species that evolved to thrive in that rhythmic wet-dry cycle are now sitting permanently submerged or permanently exposed. Neither condition is survivable long-term. Within weeks, the intertidal ecosystem, which forms the base of the marine food web for billions of humans, begins collapsing from the bottom up. 3 billion people on Earth depend on fish as their primary protein source. The collapse of the intertidal zone begins cascading upward through the marine food web within 60 days. The fish populations that feed on intertidal organisms, declining. The larger fish that feed on them, following. By month 3, global fisheries are reporting catches down 40%. The world's most efficient protein source, disappearing. The ocean current disruption reaches the atmosphere by month 2. The Gulf Stream, weakening. The monsoon patterns of South Asia, which feed 1.9 billion people, shifting by weeks. Rainfall that should arrive in June, arriving in October. Or not at all. The agricultural systems that feed humanity were engineered over 10,000 years around a climate stabilized by the moon. Without the moon, the climate stabilization system is running without its primary input. 1,000 years without the moon. Earth's axial tilt has drifted from 23.5 degrees to somewhere between 15 and 35 degrees, fluctuating unpredictably. The seasons have become unrecognizable. In some latitudes, there are now no seasons at all. In others, the temperature swings between summer and winter are so extreme that only the hardiest species can survive. Mars shows us exactly what this looks like. Mars has no large moon to stabilize its axial tilt, and it wobbles between 10 and 60 degrees over millions of years. The result, a planet where climate has been catastrophically unstable for billions of years. A planet that may once have had liquid water, and lost it, to precisely this mechanism. Earth without the moon, is Earth becoming Mars? Not immediately. Not in our lifetimes. Not in 1,000 years. But the trajectory is set the moment the moon disappears. Earth, freed from its gravitational anchor, begins its slow drift toward the condition of its nearest neighbor. And the species living on its surface, following the same path as whatever once looked up at a Martian sky and watched its world become cold. Life does not end. Life has survived 5 mass extinction events in 4 billion years, events that killed off 90% of species each time, and rebuilt from the survivors. The deep ocean, where tidal influence is weakest and the conditions most stable, becomes the refuge. Creatures that live in the cold, dark, pressurized abyss, unchanged for hundreds of millions of years, will outlast everything that evolved under the moon's light. And here is the thought that will follow you to sleep tonight. The moon is covered in craters. Every single one of them is an impact that was aimed at Earth. The moon has been absorbing asteroid strikes intended for this planet for 4.5 billion years. Without the moon's gravitational mass acting as a deflection field, the rate of large asteroid impacts on Earth would be 200 times higher. Every extinction event you've ever studied, the Permian, the Cretaceous, the Ordovician, happened with the moon's protection. Without the moon, Earth doesn't just lose its tides and its axial stability. It loses its shield. The asteroid impact rate increases by 2 orders of magnitude. An extinction-level event, the kind that wiped out the dinosaurs, which currently arrives once every 100 million years, would arrive every 500,000 years. Life would not get 65 million years to rebuild between catastrophes. It would get 500,000. The math of extinction, completely rewritten. The moon rose tonight. As it has, without a single exception, for 4.5 billion years. It will rise tomorrow. You won't think about it. You've never had to. But now, for just one moment, look at it. Not as decoration. Not as romance. Look at it as the engineering marvel it is. The gravitational anchor of your planet. The shield against the void. The metronome of every living thing that has ever drawn a breath on this world. Look at it, and understand, for the first time, what you would lose. If tonight changed the way you look at the sky, you know what to do. Like this video. Subscribe to ImagineIf, where imagination meets reality. And never miss what's coming next. Next time on ImagineIf, beneath the American West, there is a supervolcano that has been building pressure for over 2 million years. Yellowstone. And scientists have just detected something they've never seen before in the data. What happens if it erupts tomorrow? Not in 1,000 years, but tomorrow that one changes everything. Coming very soon.